13 balls are numbered 1 to 13 and placed inside a dark hat. If a magician pulls 2 balls out of the hat, what is the probability that at least one of the ball is prime? Before we start, I suggest that you try this one out on your own. Okay, good. So let us begin. So for problems like this, probability that we have at least one of the ball, the best method to deal with this is to use what we call complementary probability. So let me write that one down. Basically, the idea is that instead of solving for all the possible ways that we could have at least one prime, we'll be solving the opposite. That is, we'll be solving for all the ways of drawing no prime at all. Consequently, the probability of drawing no primes in this case. Okay, so to do that one, we begin with identifying first the primes and the non-primes in this problem. So in this case, we have numbers 1 to 13 inside the hat. So from the numbers 1 to 13, let's list out the primes and non-primes. So let's start with the primes. For the primes, we have 2, 3, 5, 7, what else? 11, and 13. Then for the non-primes or the composites, not really composites, because we have 1 here. So we have 1. So recall that 1 is not a prime, because by definition, prime must be greater than 1. So we have 1, 4, 6, 8, what else is missing? 9, 10, and 12. And let's calculate how much the cardinality of these two. For this first one, we have 1, 2, 3, 4, 5, 6. We have 6 here. Let's write it here. For the second one, we have 1, 2, 3, 4, 5, 6, 7. So we have here 7. 6 and 7. Good. So once that we are done with that, the next step is to calculate the total number of possible outcomes. So calculate, let me write that one down. By this I mean, we will be determining the total number of ways that we can draw the numbers 1 to 13, 2 of them in the hat. So to solve this one, we'll be using the combination formula. That is, we'll have here 13, since we have 13 selections, and then we will choose 2 out of it. So we can also write it as 13, choose 2 here, and this will give us 13 factorial over 11 factorial times 2 factorial. So if you don't know, factorial basically means that it is given by 13 times 12 times 11 and so on until you reach 1. So let's stop here at 11 factorial. Oops. We stopped at 11 factorial because we have an 11 factorial in the denominator, so we can cancel out that one. 2 factorial is simply just 2, so let's write 2 out here. From here, let's cancel out. 11 factorial will be gone, and then take note that 12 divided by 2 is given by 6. 6 times 13 is simply 78. Yeah, 78. So this is the total number of ways that we can draw 2 balls out of the 13 that we have. 13 distinct balls that we have. Once you have that, this is where our complementary probability kicks in. This time we calculate, so let's just copy this one. We now calculate the number of ways to draw no prime. So let me write that one down. So to calculate this one, basically, we'll be counting all the possible combinations. So of 2 primes in our case. So we'll have probably like 2, 3, what else? Of no primes rather. So let's see, 1, 4, 6, 8, 9, 10, and so on. So to do this one, basically, we have already calculated our total selection of non-primes. It is this one. So to calculate that one that we just illustrated, we'll use again the combination formula. we use 7 choose 2. So similar to above, we'll have here 7, 2, and then this is just equal to 7 factorial, 5 factorial, and then 2 factorial. By the way, if you don't know, basically in this one, the form is that if we have, let's say, n and r, then this is just equal to n factorial over n minus r factorial times r factorial. Okay, and then simplifying this, similar to earlier, it can be obtained that this will be equal to 21. So I'll leave that one as an exercise, but it's pretty straightforward, same to this one. So now that this is out of the way, we can now compute the probability. So calculate the probability of drawing no primes. So to calculate the probability of drawing no primes, capital P, no primes, basically we just divide these two, since this one is the total number of ways of drawing no primes, and this is the total number of ways of drawing the everything, the 2 balls. So we'll just have here 21 over 78. And then we're almost done. If we know this one, then the probability of drawing the opposite of no primes, so basically at least 1 prime, and if you recall, this is actually what we want, the probability of getting at least 1 prime. So to solve that one, using this one, all we have to do is to subtract 1 minus 21 over 78. So the idea here is that this one will obtain a some percent here, and 1 here represents the 100%. So essentially, this represents the complement of this. So given that, simplifying, this will just be equal to 57 over 78. Okay, so this one is 78 over 78. And then if you want to simplify further, maybe let's just put it here. If you want to simplify further, this will be equal to 19 over 26 via lowest terms. Or in percentage, if you want, we'll have 72 point, oops, not 72, it's 73.1%. And this is the answer for this problem. So yeah, it's kind of straightforward if you know this trick. But you can also actually solve this by computing probability of getting 1 prime plus probability of getting 2 primes. But that is more lengthier than this trick. So yeah, I hope you enjoyed that one. If you have any questions or suggestions, feel free to comment that one down below. Besides that, have a great day.